Welcome back to the channel, guys. So today we will be solving our second question on our series of the application of first law of thermodynamics with subtopic steam turbines. So this question states that a saturated water at 10 bars is fed to a heat exchanger with a flow rate of 10 kg per minute. It is heated isobarically to 300 degrees Celsius. Calculate the final state of water, change in enthalpy, and compare the volumetric flow rate and flow in and flow out. So at saturated water, we have it at 10 bars and flow rate of 10 kg per minute. Heated isobarically to 300 degrees Celsius. Isobarically matlab pressure is same, but the temperature is 300 degrees Celsius. Find out the final state of water and the change in enthalpy and the volumetric flow in to flow out. We need to calculate the compare. So at 10 bars, at 10 bars, we will be having your HF. At 10 bars, we will be having your HF at 763 kilojoules per kg, and your specific volume we will be requiring, we will calculate it right now only, or look it up in the steam tables, 0.00112 meter cube per kg. At your Tsat at 10 bars, it is given as 179.97, and your final temperature is 300 degrees Celsius. So the final state of water, what is the final state of water we will be having? That is the final state of water, that is superheated steam. With this, we solve the first part of the question, and the value of H2 at 300 degrees Celsius and 10 bars. H2 will be 3051.2 kilojoules per kg, and your specific volume is 0.2579 meter cube per kg. So the second part of the question, we will be calculating delta H. So what is delta H? It is H2 minus H1, this value, subtract from this value. So we will be getting 2287.5 kilojoules per kg. This is your value of delta H. So with this is your value of delta H, and the delta H, if we convert it to, we need to find out it in kilowatts. So for kilowatts, we will be multiplying this by, if we multiply this by 0.167 kilojoules per second. So kilojoules plus kilojoules gets cancelled, kilojoules per second, which is kilowatts. Joule per second is watt, and it is kilowatt. The value is 382.3465 kilowatt. So the third part of the question, which is volumetric flow rate, and we need to compare the volumetric flow rate. So volumetric flow rate is in meter per second, which is mass flow rate into your specific volume. The mass flow rate, it is also equals to A1 V1 over mu1.